Hello, I'm Seung Lee from Seoul National University, South Korea, and the title of my talk today is Molecular Systematics of World Rosalia Beetles. And I only have some preliminary results here, so please bear with me, and let's get started. The Rosalia longhorn beetles are, of course, a member of longhorn beetle family Ceramicidae, and there are so many reasons why we study these longhorn beetles. First, they're a very diverse family. They contain more than 35,000 species all around the world, and there are many species still need to be described. And by studying them, we can understand the ecological and evolutionary aspect of phytophagous beetles. And there are also many species very important economically. There are many important pests, but there's much more important reason for me, and maybe for all the Ceramicid people. You can see they're just too beautiful to just pass by. So their beautiful appearance is the main fuel for me to study these beetles. And I can say that the Rosalia beetle is one of the most gorgeous taxa in this family. I took this photograph in 7 years ago, and encountering this beautiful beetle in the nature was just a mind-blowing experience to me, and that drove me to study the evolution and systematics of longhorn beetles. So it's very grateful to have small systematic contribution to this taxa. And let me start with the brief introduction of the genus. The genus Rosalia contains 26 species from 3 different subgenera, and they're a member of the Consucerinae subfamily Ceramicinae. The subgeneric system is totally based on the body color and their geographical range, and let me point one by one. The other subgenus Eurybathides is the monotypic subgenus, and they're only distributed in southwest China, near Yunnan province. And the blue subgenus Rosalia sensu stricto contains 5 species, which distributes West Palearctic, Oriental, East Palearctic, Japan, and Western Arctic, respectively. And the red subgenus Eurybatus contains 20 species, and they all distribute in the Oriental region, including Taiwan and Japanese Ryukyu Islands. And there have been some conflict about the subgeneric system of this genus, but all of them divide the genus into 3 according to their body color, because the body color is too obvious. And according to the recent review of the genus, they say that the yellow Eurybathides is the most distant group in the genus, but their phylogenetic affinity has never been studied in the formal framework. So that brings me to my research object. My research object is quite simple. I want to unveil the internal relationship of the genus and test the validity of the current subgeneric system of this genus. And I will plan to conduct the phylogeographical and ancestor stage reconstruction analysis for this genus. But the latter 2 are just ongoing process, and I'll briefly mention about my future plans about these 2 subjects. So the main part, molecular phylogeny. We just follow the basic steps of multi-locus molecular phylogeny. For the taxon sampling, I collected some beetles by myself, but most of the samples were obtained by sample exchange or donation. So this is a final taxon data set. We included all 5 species of blue Rosalia, and we also included this very important yellow subgenus Eurybathides, and 7 species out of 20 species of red Eurybathides was included in this research. And for the outgroup species, we selected Hyloturpus bodulus. This species recovered as very closely related species to the genus Rosalia in the previous molecular work. And we also included 1 species from the same tribe, Consucerinae. And for DNA data set, we use multi-locus data. We use CO1 and some nuclear protein coding genes like CAT and wingless, and traditional ribosomal RNAs like 18S and 28S. So our final data set composed of more than 5,000 base pair of nucleotides. And for tree searching, we use IQ Tree and Mr. Bayes. Yes. And this is the final topology we got. There was no conflict between maximum likelihood tree and Bayesian tree. And the genus Rosalia was recovered as monophyletic with high supporting value. And also the red subgenus Uribatus was also recovered as monophyletic with high supporting value. However, interestingly, and this is the most interesting part of my phylogeny, the blue subgenus Rosalia recovered as polyphyletic, and the yellow subgenus Uribatus was included inside the main plate, main upper plate of blue Rosalias. So, yes. So, according to this tree, we can divide this genus into 4 subgenera, maybe. They are all divided clearly according to their geographical range. However, there are some problems in our phylogeny tree because some nodes are supported with very low supports, especially this one is the Nearctic species, Rosalia funiverse. And this species act like the rogue taxa in this phylogenetic tree because they have very low supporting value in both analysis. And when we add some genes or excluding some genes, the phylogenetic position of this species changes a little bit. So at this point, we can only conclude that this genus Rosalia is monophyletic lineage, and because we are lacking the robust enough tree, we have to leave this without subgeneric system until we got the robust phylogeny. And now we know that we should never use color as the important character. It's quite obvious. It was thought to be very obvious character in this genus, but the color was not an important character in this genus. So this brings us to the summary part. So this is the summary. Uribatus is clearly a member of Rosalia, and the Rosalia is monophyletic. The red subgenus was monophyletic, and the blue subgenus is polyphyletic. And the color is not a decent character for subgeneric system. So this is the end of my molecular phylogeny, and I will briefly introduce my future plan of the Rosalia study. I will put this Rosalia tree into the previous molecular tree of Strabiscine, the sub-family tree, and then I'll conduct some fossil calibration and conduct some phylogeographical analysis to understand their characteristic distribution. And okay, so this is a very interesting part, but I'll very briefly talk to you. So if you have any question, please talk to me after my talk. There was a remarkable variation on the elytral pattern of this blue Rosalia species. So I want to understand their parent formation, how their parent form. So what I wanted to do is just gather as many as images as possible, and then analyze the intraspecific variation using computer vision analysis. This is like AI-based pattern-seeking analysis. And then we get some trait values from the analysis. And using this molecular tree and the trait value, I think we can reconstruct the hypothetical ancestors' elytral pattern. So these are what we got by far. But I only gather the information about the blue Rosalia. But the blue Rosalia recovered as polyphyletic in this study, so we have a long way to go, and we are changing our plan to how to make it right. So this is what I prepared for today, and thank you for listening, and thank you.